These are the notes for finding the area and perimeter of regular polygons. So the first example, we're going to find the area and perimeter of a regular hexagon, so that's 6 sides, with a side length of 10 inches. So I'm just going to fill that in right here, 10 inches. So the first thing that you did when you were discovering this method was you broke up your polygon into triangles. And you did that sort of pretending there was a circle around the polygon and using the center of the circle as the place where you put the vertex of those triangles. So that's the first part. And then the second is we need to find one angle measure up here. So we'll call that X for right now. Excuse me. You'll remember that there are 360 degrees in a full circle, and that each of these triangles have the same angle measure up here because they're all isosceles triangles with the same length because these are radii of a circle. So I can divide this by the number of triangles I have, which is 6, and that gets me 60 degrees. So X equals 60 degrees. My second step is to draw the perpendicular bisector from the vertex angle of one of these triangles. So we've just kind of copied down one of these triangles here. I draw in my perpendicular bisector. And now I need to find this angle measure and this angle measure. Well, this, if I've bisected the perpendicular bisector in an isosceles triangle, cuts the vertex angle in half. So if that whole angle was 60, that means this is going to be 30. And because the angles add up to 180, and so 30 plus 90 plus 60 is 180. So now I need to find the height and the base of this triangle in order to find the area of this triangle. If I can find the area of this one triangle, and I know that I have 6 of them, 1, 2, 3, 4, 5, 6, I then can find the area of the entire polygon. So in order to do that, we have the base already. We know that the base is 10, but I need the height. And so in order to do that, I'm going to have to use some trigonometry. I know that this was the perpendicular bisector, so this is a length of 5. And I know I need to find the height. So looking at this triangle, I can see that I'm not going to do anything, at least right now, with the hypotenuse. And so I'm going to use the tangent function. And because I find my life is a lot easier when I can have my unknown in the numerator of my fraction, I'm going to do tangent of 60 because that gets me my opposite over adjacent. I'm going to solve for h, the height. I do that by multiplying both sides by 5. So that 5 times tangent of 60 equals h. Then I'm going to take out my calculator to find that. So 5 times the tangent of 60. And that gets me a height of about 8.66. So my height is about 8.66. So now I have the height and the base, so I can find the area of the triangle. So remember, area of a triangle equals base times height divided by 2. Now, I want my answer for this area of this triangle to be as precise as it possibly can. So I have my base as 10, but I'm going to leave my height in terms of what we found h to be before I used my calculator. So this step right here was kind of an extra, like, oh, by the way, you can find this as a number, but I don't actually want it as a number at this point exactly. So then I'm going to say 5 tangent of 60. So again, I'm actually not going to find an approximate value right now because I want my answer in the end to be as precise as possible. So I'm going to move right to finding the area of the polygon. And in our case, that's going to be 6 times the area of our triangle. So 6 times 10 times 5 tangent 60. And now I am going to pull out my calculator. And I'm going to find, I plug all of that in, 6 times 10 times 5 times tangent of 60, that I'm getting an area that is approximately 519.62 inches squared. My last step here is to find the perimeter. And I could have actually started with this since in this case they give us a side length of the hexagon, so that the perimeter of the hexagon is going to equal 6 times the side length. So perimeter of the hexagon is going to be 60 inches. Let's look at a second example. In this second example, we are instead given not the side length of the polygon, but instead we're given the radius of the circle to be 8 centimeters. So when I decompose the polygon into triangles, doing that for a 12-sided figure is a little bit messy. But I can use the same methods I just used a moment ago, which is to say that I know that one vertex angle is going to equal 360 divided by 12, which equals 30 degrees. So then when I draw in the perpendicular bisector for my triangle, I know that this 30 degrees is going to get broken up in half, and so that makes this 15 degrees. And similarly, because I know these two angles add up to be 90, I know that this is 75 degrees. So in this case, I have to find both the height and the base. I'm left with neither of them. So I'm going to label this the height and this the base. And then I'm going to do kind of an in-between label. I'm going to label just this little side K. So again, using trig, I can find H and K. So I know that in this case, I'm going to need to use the hypotenuse, so sines and cosines. And again, I want to make sure that that one of these is in the numerator, that these are in the numerator when I set them up. So maybe I'll use cosine of 15 equals adjacent over hypotenuse multiplied by 8. So now we know that H equals 8 cosine 15. I then can find K using that same idea. I'm going to use the 15-degree angle since that's the one that I found using the method of the decomposing the polygon into triangles. So I'm going to say that now I have sine of 15 equals opposite over hypotenuse. So I multiply by 8, and so I get that K equals 8 sine of 15. But we'll remember that finding the base here, that the base is 2 of these K's. So we would say the base equals 2K. So that's going to equal 2 times 8 sine 15. So the base equals 16 sine of 15. So now I can move into the area of my triangle. Base times height divided by 2. Base in this case is 16 sine of 15 times my height is 8 cosine of 15 divided by 2. And I'm going to simplify that just a little bit here because I can divide 16 by 2, and that gets me 8 sine of 15 times 8 cosine of 15, which actually can be simplified to be 64 sine 15 cosine 15. So there's the area of that one triangle. Now to find the area of the 24gon, I need to do 24 times this area for this one triangle. So 24 times 64 sine 15 cosine 15. And this is where I take out my calculator and I do 24 sine 15, and then I'm very careful to close my parentheses here. That way I've finished with the sine part, and now I can put in the cosine part, cosine of 15. And it turns out that that equals which is not right. So let's double check that. I missed something. If you'll notice, I missed the 64 part. So I actually need to multiply this 6 by 64. Now that makes a lot more sense. So in this case, the area is an exact value. I don't have to have an approximate. And the area is 384 centimeters squared. So the area of the 24gon equals 384 centimeters squared. So the perimeter, remember the perimeter of this 24gon is going to be 24 times the base. So we need to go write down what our base equaled, which was 16 sine 15. So again, I pull out my calculator. And this time I'm going to be very careful that I say that it's 24 times 16 sine 15. That will give me a much better answer. And I find that the approximate value is 99.39. So this is 99.39 centimeters. So two different pieces of information. In the first example, we were given the base, or the side of the polygon. In the second, we were given the radius length, if you imagine the polygon being inside of a circle. And the two different ways of doing that.